Morning. I'd like to break from the heat and humidity of Florida for a minute here and take you to a cooler place. Ask you to think about what you see here, the white stuff. And think of how you would describe this to somebody. Maybe someone you know, maybe someone you don't know. And I'm going to talk about kind of the formation of these ideas and how we translate them. And then I'm going to talk about security as well and try to merge the two together. But first I want to talk about how we represent our ideas. So in the English language at least, there's kind of a common word we'd use, just snow. It's pretty straightforward. If you're describing the white stuff, it tells people what's going on. I'm a skier, so to me that's not satisfactory. I want to know what type of snow is it? Am I going to enjoy skiing on this? Is it fun? Is it, what kind of skis should I bring? So let's look at these situations. I'd say that we could still describe all of these with the word snow, but as a skier, I have a more refined view of these things. And so for the first one, that's the same picture we saw before. I may say something like, this is powder, as an image in my mind of soft, fluffy snow that's just fallen. If you go to the right, this is snow that has been melted and refrozen, melting during the day, freezing at night. Often you see this in the springtime, and we call this corn snow, because it kind of kernelizes into small chunks of ice. On the lower left, we have a machine that's just gone over and smoothed out the snow, so we call this a groomer, based on the grooming machine. And then on the lower right, you can see the bumps. Some people enjoy these, some people don't, but these are what we'd call moguls. And so by being around the snow, by being exposed to it a lot and around people who ski in it a lot, you develop terminology that's more specific than just the generic term. So I want to take this one step further and look at a group of people who spend their whole lives surrounded by snow. They live in snow. They build their houses out of snow. And these are the Eskimos in northern North America. And here's a list of roughly 100 words that they have for snow. And so they have all of the common ones we would have. The top one is powder snow, snow that is crusted on the surface. They also have some strange ones. There's one here, a mouthful of snow because you fibbed. So I'm assuming that's kind of a cultural reference to if somebody says something they shouldn't, they shove snow in their mouth. In America, we might call that washing your mouth out with soap and water, but they use snow. So there's 100 ways they can describe snow because they're surrounded by it. So what I'm getting to here is that we have a sense of granularity when we describe things. That the more familiar you are with something, the more part of your culture it is, the better granularity you get in describing it. And so the skier on the right there, if you're talking about that snow, at the broadest level, you could just call it snow. But if you want to really narrow it down, you can call it champagne powder, which to a skier conjures up this image of the light, fluffy snow that flies in the air when you ski through it. So it's a vivid image. If you're talking about the numbers on the right, to a normal person, they're just numbers. To a programmer, those are a static, unsigned int array of length 24, which to them would be very important to understand how to use those numbers in a program. You could look at a document and just say, I'm going to send you a document with some text, or you could say it's going to be a Word version 97 to 2003 compatible. And that tells you what program you can use to open it and certain other properties about it. And depending on the context, the broad description may be appropriate. If you just care that it's snow versus sand, snow is fine. But if you really need to know what kind, champagne powder is a better description. And so you can do the same thing even for the color red. I can give you the exact numerical value of that red on the screen here that tells the computer how to display it, or I can just say, hey, it's red, and you know what I'm talking about. So the idea is that our ideas are somewhat unbounded, infinite, continuous, very fluid things, but the words we use to describe them are discrete and finite. A dictionary has a defined length. Some dictionaries are longer than others, but it's something you can hold in your hand. It's definitely finite. The set of ideas you can have expands way beyond the dictionary and the words. People can write entire books on these concepts. You come up with a new business term, and you can write a whole book describing it. And so you've essentially created a new word by using other words. But in a normal conversation, you can't afford to recite a book every time you want to express an idea. So we use shortcuts, and we use imprecision with our language. So suppose you have an idea now, and you convey it to somebody with language or a picture or any form, some representation of that idea. we still have the problem that you have to repeat it. You hear something you like, you want to tell somebody about it, you have to repeat that message. And so this reminds me of the childhood game we'd play where a teacher would whisper something to a child, and we'd sit a bunch of children around in a circle, and each child would in turn pass on the message to the next one. Until the end, the last child would announce what they heard, and then the teacher would say what they had really said, and the two were completely different. There was almost no resemblance, and sometimes it was because one of the kids had been kind of playing around and just made up his own message halfway through. But even when they tried to convey it, they failed miserably. Just humans are not good at repeating. And so we have this distortion that creeps into our messages when we try to repeat them. We'd think that with email, we could solve this. I mean, email is a digital representation. You click forward, and it should send the same thing on, and you can do that as many times as you want. In reality, I have not seen this happen. Every time I get an email forwarded 5 or 10 times, each time it indents it, adds special characters, or changes the font, or changes the spacing, the tab settings. And so a nicely formatted message turns into what might be just a vertical string of text on the right with randomly inserted other characters throughout the text. So that even digital representations have this challenge, that repetition eventually introduces distortion that can be a problem. Let's look at the bottom right here is a YouTube video. The one on the left is actually the original video. This guy created a video of himself talking. He uploaded it to YouTube and then just downloaded it again, uploaded it again, downloaded it again, and did this 1,000 times. And you think it's just a simple video file. You just send the file up, you bring it down, nothing changes. Well, it did. After 50 or 60 times, you get the middle one where there's distortion and, you can still recognize it, but it's not as clean. And by the time you get to, I think, 474, you get the one on the right, which is just this kind of psychedelic picture of this, kind of looks like a person moving around. And if you listen to the audio, it's just complete garbage. You can't hear anything. So you've taken this nice clean file and you just basically shuttled it around, re-encoded it each time, but it's the same information re-encoded. And it goes from nice and clean to just completely unintelligible after a large number of iterations. But you can see that these small level changes in the representation of the high level idea, they're not trying to change the idea. They're just trying to change little tweaks in how it's represented. But if you do enough of those and repeat it enough times, you start to actually change the message. And so the original guy talking now becomes kind of a new art form. If you look at the one on the right, you get a completely different impression of what is being conveyed. So I finally want to get here to, I've lost my mouse, to translation. There we go. Okay, so with translation, we have the trouble that when we convey an idea in a language, there's a set of context associated with that. And when we move from one language to another, you don't maintain the context, at least not in the case of the picture on the right. We can see obviously that they tried to translate what appears to be a Chinese sign for a disabled person restroom, and they came out with deformed man end place, which you can kind of see technically how that might be, word for word a translation, but you've completely missed the meaning of what you're trying to convey. And it's not an appropriate translation. It's not something you would ever say in English. It's kind of insulting to a person who is disabled, and end place doesn't really mean anything in English. So you've kind of missed it. And I think all languages have this. There's a set of ideas that are not apparent when you're reading the language, but when somebody from that language reads it, they bring in the context. And when somebody in another language doesn't have that same context, they get a different impression. So the same thing is true with computer languages as well. Certain languages are designed for certain optimizations. You may have linked lists and recursion in one. You may have arrays and pointers in another. Trying to work between the two can be very difficult. And when you convert it, it may be technically correct. It may run properly, but it may be inefficient. It may have artifacts, things that you didn't expect. And the same thing here, I think it's the same thing as language, where you kind of get the technical, the basic meaning, but you miss some of the context and the subtleties. And the problem here with translation is that you're also taking a representation, trying to abstract the ideas, which is a granularity issue, and then recreate another representation. So you have a double granularity problem as well as you're repeating the message, so you end up with the problem of repetition where you introduce distortion. So bottom line, I don't think anyone here disagrees that translation is inherently inaccurate. It's difficult. You miss something. And it's not something that people are bad at translating. It's a fundamentally hard problem. So I want to stop there with translation and now take a look at security, because eventually I want to put these two together if we can. So when I talk about security, my work is in enterprise level security, which deals with a large group of people sharing between each other. I'm just going to focus on the end-to-end aspect of security to say that I want to talk as me to someone I know and I trust without anybody else being able to see or know what we're doing, and with assurance that I know who the other person is. So there's three basic aspects that I want to stress here. One is that I know who I'm talking to, and they know that it's me. If I don't know who I'm talking to, I can't have a secure connection. I could be talking to the CIA, I could be talking to another government, or it could be my coworker. I don't know. So I need to know who that is. And there's digital methods for doing this. We use smart cards with digital certificates as one of our approaches, but there's a number of ways you can do it. You can even use the bank approach and ask all your personal information, your mother's maiden name. It's all just a method to identify who's on the other end of that line. So the second step, once you know who it is, you don't want anyone else to know what you're saying. So encryption is the basic technique we use here. We establish a key, a shared secret between us, and we use that to encrypt the data back and forth so that even if somebody else sees the data, they won't be able to know what it means. So that's how we do end-to-end. I know who you are, I encrypt it end-to-end. But we still have the problem that somebody in the middle, especially in the internet, can see what we're sending. They won't know what it is, but they'll see that we're sending something, and they can delete parts of it. They could repeat parts of it. They could add their own message, they're garbage essentially, or they could reorder things that we're saying. So if, for example, if I'm responding with yes or no questions, they could switch the yeses and nos, which could change the meaning of our conversation. So the third part just says that you can't change anything that's happening. A third party can't come in and mess with our conversation. And if they do, we'll figure it out and we'll start from scratch and communicate securely again. So those are the three aspects of end-to-end security. You may have heard this in the news about law enforcement having trouble breaking end-to-end security when criminals are using it, but I'm thinking more in a positive light, that I want to be able to talk with somebody across the world as if they're right next to me in a private room having a private conversation. I think that's a valuable thing for people to be able to do. So what if the end-to-end people, or the people on the ends, don't share a common language, or in the computer world, a common representation of data? You can think of trying to book a hotel. If you're visiting China from America, they may not speak English, and I certainly don't speak Chinese. So we need someone to translate for us. You have the case of, I write a Word document, I need to submit it as a PDF to a conference. I need to translate that document into a new format. We have English and metric formats that has been an ongoing challenge. And we have different programming languages, different representations of images and data. There's all sorts of types of translations that we need to do. And often these are kind of behind the scenes. We don't notice them, but they're happening. Every time we load an image on a computer screen, there's some sort of translation happening there. And even an address. If I tell you to come to this conference, I tell you the address. But you probably want to find that on a map first and figure out where it is in relation to other aspects of Orlando. So now what if we need really secure end-to-end security with translation? And this happens a lot with sensitive medical information between hospitals, say. They may use different representations of the data, so they need to translate it, either one end or the other, or somewhere in the middle. You have all sorts of personal information that you're sending all around. There's a lot of cases where, I think a growing number of cases, where you have sensitive data that has to flow through different data formats. And so the fundamental challenge here is that we have end-to-end security, which we've kind of figured out. We know how to do this. We have the mechanisms. That's a two-party problem. What we have now is a three-party, because we bring in a third party to do translation. The two endpoints can no longer talk by themselves. We need some other entity, either digital or human or otherwise, to come into this conversation while maintaining security. And so we have a way to do this, which has been around for a couple hundred years, according to Benjamin Franklin. Three may keep a secret if two of them are dead. So it's a very, I'd say he kind of sums up the problem and the solution in one phrase here. But that's not a good solution for us. We're looking for ways to do this. while keeping everybody functioning and alive. So I'm going to give you a few attempts here that we have and highlight some of the security problems with them and hopefully find a way forward that we can solve some of these issues. So the first attempt is pretty straightforward. In keeping with the other speakers here, I have a picture here related to the conference. So the idea here is we want to load the WMSCI speaker page, but we want to load it in Arabic. So we go to Google Translate, we say, here's the page I want to see, here's the language I want to see it in, and there it is. There's our page in Arabic. So that's a pretty simple, straightforward, universally accessible, and fairly decent translation. How does this stack up security-wise? Well, not very well. So if we look at some of the issues here, the first is, do I trust this go-between? Do I trust Google Translate or any other service to go out and get the data for me and then provide me the translation of that data? I might trust them, but I might not. Do I trust them with the information? Do I trust them with the fact that I want that information at this time? With the fact that I probably don't know the language that it's in, and I do know the language that I'm requesting? There's a lot of metadata here. There's a lot of data that I'm releasing to a third party about this communication. In this case, no big deal. But if you can imagine, sensitive data that you don't want released, this could be a problem. So another challenge here is that the website I'm going to might not trust the go-between. In this case, it's a public site. They trust anybody. It doesn't really matter. But let's say that you have data that's tied to a personal account, your personal health information. The hospital that holds that probably won't release that to just anybody. You'll have to log in as you to get access. And Google Translate, for example, won't have that access. And so you have a fundamental problem here that you can't get to the data. And it's similar if you have data that's not publicly accessible. If you have data that you own inside your organization or just your personal data, Google can't find that. A public site is not going to be able to come in through your firewall and search through your data to find something to translate for you. You'll have to host something internal. So another thing that is not so much it's a problem that you just can't use this technique for that kind of translation. What if I don't want to know, or I don't want Google to know everything that I'm seeing? Well, I can't stop them. I'm telling them to get the data first. So they see it before I do, and then they translate and send me what they want to send. And the final thing kind of is last, but certainly not least, is that I don't know if what they're sending me is representing the original content. They could send me, I could be requesting an article on cats. They could send me an article on dogs. I wouldn't know the difference because I don't know the language. I wouldn't be able to tell. So that's kind of a fundamental mismatch that you can't even figure out. There's no method built into this access method, this translation method. There's no way to confirm that the data is accurate. So let's try again. Let's take attempt 2. Instead of going to Google Translate first, I'm going to go get the data first. In this case, I'm going to download, in this case, an Arabic site or the Arabic translation. I'm going to take the data I have now, send it to the translation service. They're going to send back to me the translation of just what I send them. So I have a little more control over the data now. I'm getting it right from the source. I know that the data is good. I just don't know what it says. Now I can go and translate that piece by piece, and I have control over exactly what I'm exposing. So we still have a couple problems. We've solved the issue of does the other endpoint trust the translation service, because now the other endpoint isn't involved. I go and I get the data, so they don't have to trust anyone except me. And also the fact that if it's not publicly accessible or it's difficult to get to, as long as I can get it, I can have the data and send it to the translation service. So that solves 2 of the problems we had. And by controlling the data I send, I have a little bit of control over validating that the translation is correct. I could send individual words one by one and have those translated. Then I could send phrases, I could send sentences, I could send paragraphs, I could send the entire document. And I should see some correlation, building up from words to phrases. It should make sense. I shouldn't see a sudden shift in meaning from words to phrases, and phrases to sentences, and so on. I won't get a good translation by doing word by word, but I'll get a sense of what's going on. And I can confirm that the translation is probably close. And the main thing here is I'm not revealing the source of the data. And so if there's a firewall or access restriction on certain data from certain places, there's no way for the translator to know that in this case. Whereas in the previous one, they could say, well, you're getting it from a site I don't like, one of my competitors, so I'm going to give you false information. It would be very hard to have a consistent falsification of the translation here. But we still have some problems, and the main problem here is related to sending the data out and having the translator see the data in the first place. So we're going to do a slightly different approach now. I'm not going to send the data out. I'm going to pull the translation algorithm back in to my device. So you can think of a mobile app where I simply feed my data into the app, it translates it, and now I have the translation. So there's no data leaving. It's just me retrieving the data I don't understand, bringing it in, and translating it myself. So this is much more secure, and you can see that we're essentially solving all the initial problems, or at least partially addressing them. I sort of need to trust the translation service because they're providing me the algorithm for translation. But with mobile apps, you get a lot of people reviewing them. They can comment, this is a good app, this is a bad one. So you have some sort of peer review here that will help you assure that it's trustworthy. We don't have any problem now about the translation service seeing anything because it's all contained on your app. And I'm making a big assumption here, which is that the app is self-contained, disconnected, and completely local. Most apps these days are actually just interfaces to a web service that's hosted in the cloud, and that's for performance and scalability. This is kind of maybe a backwards-looking approach, but it's one that preserves security. So it's something, if you had the cloud version, you're essentially rolling back to the translation service of the previous example. So in this case, we have a good solution security-wise. The question is, can a mobile device do this translation? And sometimes yes. If it's metric to English conversion, it's just multiplying or dividing by a number. That's easy. If you're talking about language translation, arbitrary language to arbitrary language, well, that may be hard to fit on a phone. It may consume a lot of computational resources and may drain your battery. So that may not be suitable for a mobile app or even a desktop. If you're doing movie conversion, it's a very computational intensive process. Even on my desktop, that takes a long time. I can't imagine waiting for a mobile device to do this. So the main challenge here, which I think this is a good place to be, we've solved the security for the most part, and now it's just a matter of letting the technology catch up and improve, which it is doing every year. So I think we're working with technology now. As speeds of processors and powers of mobile devices improves, this will become a better solution. I have one more solution that is looking even further ahead, and it involves the idea of homomorphic encryption. I don't know, has anyone heard of this term? We have one person, excellent. Okay, so let me talk first about normal encryption. So we have 4 values here on the left, our input, the numbers 1, 2, 3, and 4. And I want to encrypt these numbers. So I encrypt them into ciphertext values C1 through C4, and you can see the values here are just random strings. They're pretty much unintelligible. And that's the design, that's encryption. Now we're going to do something a little strange. We're going to take these numbers, these encrypted numbers, and multiply them together and get a big number now, our output. So what happens now if we try to decrypt that value? Are we going to get anything? What are we going to do? Well, you may not be able to decrypt it depending on the algorithm, but let's suppose you can. Say AES 256, for example. You're going to get garbage, just complete meaningless garbage as output. Normal cryptography is not designed to operate, to process on this encrypted data. It's just a rock that you create and then decrypt, and that's it. Well, let's take a step back and look at homomorphic encryption now. Homomorphic encryption is designed so that you can operate on the data. So in this case, when we multiply the homomorphically encrypted data, the output decrypts to 10. And if you'll notice the inputs and the output, there's a nice relationship. The 10 is just the sum of all the input values. So by multiplying the ciphertext, you've effectively added the plain text, which I think is pretty amazing. There's different techniques. Sometimes you can multiply and multiply. You can multiply and add. There's different relationships you can create here depending on how you encrypt. But I want to highlight that in 2009, we went a step farther, and Craig Gentry's thesis released a method where you can actually apply any operation you want to the plain text by using an operation on the ciphertext. So we could take the encrypted English Bible on the left, and we could have an algorithm in the middle that doesn't know the data it's operating on. but it could operate on it and produce an output. When we decrypt that, we now have the Spanish Bible. So it's actually translated it without knowing what it's translating. The caveat is, well, we've essentially solved all the security problems and we've gotten rid of the dependence on the device. We can now do this in the cloud. The problem is that this processing is very intense. I mentioned addition becomes multiplication. You can imagine translation becomes super difficult, complicated, very hard translation. And it's orders of magnitude we're talking. So it's not like it takes twice as long, it takes 1 billion times as long. So currently this is not feasible, and the implementations that I've seen are, millions to 1 billion times slower. But this has only been around for a few years, so we anticipate fast growth and rapid improvement in the algorithms and the performance and the hardware that implements it, that this might actually become feasible. And then the advantage here is we can take these fundamentally insecure methods that we started with and apply homomorphic encryption, and now they become secure. So it's a nice technique in software that we can patch up methods that just don't work otherwise. So why does all this matter? Well, the other speakers have kind of hinted at some of the reasons here. They mentioned a lot of good details about Internet of Things and how it's going to dwarf human communications, and in fact already does by a lot of measures. The problem I see is security for IoT is not a big priority. And so I think there's a rich ground here where you have these devices that are manufactured by different manufacturers, different protocols, a lot of proprietary data formats and communication protocols. There's going to be a lot of translation necessary to get these to work. And we're going to need to enforce security to preserve people's privacy and just the general integrity of the data that's flowing. So I see that as a big area that we need to merge the idea of this translation between digital formats and the security associated with this end-to-end communications. The other problem I see is that these exploits are becoming automated. And I mentioned a couple here, SAML wrapping and these certificate attacks are methods where the human to computer representations have poor translation algorithms. And so there are people who have attacked these and kind of snuck in. They make something that looks human readable and looks good, but they add a couple special characters to it, and now the computer interprets it completely differently. And so by automating these, you can quickly find a translation error and exploit it very rapidly and with a widespread exploit. So we're seeing more of these that are happening faster. And so I think if we can secure our translation, we can prevent some of these and at least make it a little harder for them to do. We see a proliferation in general of formats for data and protocols for communication. We keep introducing new ones, and we rarely get rid of the old ones. I work in the government, and we have systems that are dating back to the old green CRT monitors that we're talking like missile control systems that rely on going through eBay looking for these old components just to keep the systems running. So these protocols are never going to die, as far as I can tell, and we're only adding new ones. And so we're going to have more and more need to translate data and keep it secure. And then getting back to the original idea of this inaccuracy in translation, when you expect inaccuracy, it's harder to detect attacks. Attacks are often found as anomalies. That's the first sign we have that somebody's doing something bad, is that something funny happens. So if you see a funny translation, like the Chinese restroom one, you may, if you assume the translation was perfect, you'd think something funny is going on here. Whereas if you get used to seeing things like that in everyday life, in all of your systems, it becomes harder to detect the real anomaly, the real attack, because you have this high degree of noise that you're starting with. So I think we need to look at the translation ideas and make sure that we can secure them end to end so that we don't introduce extra noise by having insecure translation, which allows real attacks to hide in this legitimate noise. So if we can reduce the noise, the attacks will stand out more. And that's a general principle we follow as well with our enterprise level security. So I want to conclude and just say that translation is everywhere, especially in the digital world. We really couldn't function without this. And I only see this increasing with IoT and the proliferation of information on the internet. But I think we need to think about how to translate data, and especially how to do this securely. If we can't do this, then we're going to have a lot of noise in our communications, which allows exploits more room to hide. And I think we can reduce the noise floor by focusing on secure methods of translation. I presented some that are not necessarily perfect, but I think it's important for people to think about these and to recognize that some are better than others, and they have limitations that maybe we can deal with better than others. So I hope we can continue to push this forward and come up with new ideas. So thank you.